Okay, so in the last unit 4 we were doing factoring of quadratics for the most part. Now we're going to be analyzing the quadratics as in terms of being a function. Okay, so we need to review what we did in Math 10, and specifically what is a function and what is function notation. So you can think of a function as a rule, and basically it's an equation, but you can think of it as like a rule. So think of this as an equation or rule that's applied to the input. Okay, so if you take a look at what happens here, x is some input value. Some input value, a rule is applied, and that's your function. And then you get this new thing called the output value. So for example, you could think of the function as like a machine. So think of it as a machine. So for example, if you input like spam or something like this, like, you know, that nasty meat that you can get in a can, it's delicious. Oh. And then the machine pumps out like chicken nuggets or something. Okay, so X is the input. Maybe that's the spam. It's this like terrible meat. Some function is applied, some rule is applied. This is the machine. And then out comes chicken McNuggets. Okay, yeah. Okay. So something specific that you need to understand is that to be a function, okay, each element of the domain is related to exactly one element of the range. They call this one-to-one. So for each x, there's exactly one y attached to it. Yeah, it's this left side you might remember as the domain, and this right side you might remember as the range. This is just the space. You could think of it as like the universe. So for the inputs, they call it the domain. That's where they all live, and then the functions applied, and now they're over here and they're in the range. Okay, and then they give you the function notation. This is very key, especially headed into Math 30-1. You need to know your function notation. It's critical. All your math, you know, after this point, anytime they're talking about functions, you'll use function notation. So let's take a look at the function notation. So it says f at x, and I'll write that over here, f at x is 4x minus 8. So that means this is the rule. What does the rule say? Everybody's with me? What does the rule say? Take x and do what with it? Take x, then multiply by 4, then subtract 8. That's the rule. And anytime you give this machine an x value, it's going to pump out a y value, and that's the input-output relationship. And you can see that here. You input a value into the function machine, and lo and behold, you output a result. And the rule says take x, multiply by 4, and then subtract 8. That's how functions work. There are so many functions out there, you wouldn't believe it. Like, you want to talk about population growth, there's a function for it. You want to talk about no, not chicken nuggets. You want to talk about anything that you can relate to a mathematical model, there is a function for it. For example, they know, there's biologists, they know, like for example, how many bears in a forest is too many bears and how many bears is not enough bears. Taking into account, like, is there enough food and population and reproduction. So there's mathematical models and mathematical functions for almost everything. Like you think about, even like I teach physics in the block 4. There's models for so many different things in our world. In the math, all you really have to think about it is like, okay, how do we do this algebraically? And you're going to see that if you can handle this, you can get through a lot of your math. This right here. If you understand this, it says y equals f at x. So what does this mean? It means our equation y, okay, is going to be some function, some rule that depends on x. So whatever you pick x to be, the function will do something to it and you'll get some y that goes with it. Okay, and here's an example of that. Here's a graph. You have your x here, you have your y here, and then here's some function. Maybe it looks like this. Who knows? This is some function. Okay, and then you can graph it and you can look at its properties. Okay, this is what we're interested in -1. Can you handle a function? Can you graph it? Can you analyze it? Can you handle the corresponding algebra? Okay, so let's take a look at this thing called zeros of a function. Zeros of a function, we did this in the unit 4. It was, do you remember the zero property rule or whatever? Or what was it called? Zero property rule? These are going to be called your x-intercepts or your zeros. They have the same, they have a different name for the same meaning. So what does it mean for a function to be 0? So it means that the y-axis, or pardon me, the y value is 0. So like if I put a point on the x-axis, this is called an x-intercept. Do you agree? This is also an x-intercept. Do you agree? What do they have in common? While they might have some different x value, what value is the same? The y is both 0. So y equals 0. This is what you're trying to solve. And we did a whole bunch of practice on that in the previous unit. Do you remember we set the function equal to 0 and then solved by factoring? That's what we're doing. We're solving for the x-intercepts. Okay, so it says find the 0. So that means y equals 0. And y and f at x mean the same thing. So you can write it either like this. Either like this or like this. It's the same thing. So over on the right-hand side, we can change the f at x, or in other words, the y, to 0. And then we solve for which x makes that happen. And obviously this is 3, right? What's 7 times 3? And 21 minus 21 is 0. So clearly this is 3. If you need to prove it with algebra, move the 21 over and divide by 7. Okay? By far, one of the most important things coming out of Math 20-1 is your ability to solve for zeros. So, this is a very simple version of it. You've had practice with it in Unit 4. Just need to remind yourself. Okay, so here is a function that's linear. In Math 10C, you spend a lot of time on linear. And in this course, we're going to be spending a lot of time on the degree 2. This is a degree 1 polynomial. We're going to be working with degree 2. So this is just like a little bit of a warm-up. It says determine the x-intercept graphically. So what is this value here? What is this value? Careful, you guys. 3, 0. It's 3 to the right and 0 up or down, right? Now, how to prove this algebraically? So you have to use the fact that y is going to be 0. Now, how would you solve this in junior high? You would move 6 to the other side and then divide by 2. You could also use your factoring. What do they have in common factor? 2. Take out the 2, you get x minus 3. Then you solve this guy. X equals 3. Okay, that's another way that you can do it. You can use factoring, because that's what you do in the degree 2 polynomials. So you could also do it with degree 1, is use factoring. Okay, it says determine the root. That's the exact same thing. I'm not sure why. They just want, okay. So this word, and this word, they all mean the same thing. Roots, x-intercepts, and zeros mean the same thing. So if they ask you for a root, or a 0, or an, they're all asking for the same thing. Yeah, they're all the same. Okay, let's move on. Okay, now let's do it for a quadratic. This is the big focus for 20-1, analyzing these functions. Okay? So what are the zeros? -2 and +3? Okay, good. And these coordinates would be 3, 0 and -2, 0. So it's okay when you're writing them as zeros to just put in x equals, and it's also okay to put them as coordinates where you can see that the y value is 0. Now to solve for these algebraically, you would have to use the zero product law. Okay, so you'd factor that left-hand side, and it's an inspection, so it's really straightforward. Factors of -6 that add to -1. I'm assuming it's 3 and 2. To make this -1, this would have to be bigger by 1. Solve these individually. And you can see the connection between the zeros and the solutions to the equation when it's equal to 0. Any questions so far? We have simple examples, but we have a big idea. So hopefully you're able to make connections here, and then we'll move forward to some harder stuff. So any questions before we move on? Because that's basically all you need to know for this. Degree 2? Degree 2 polynomials always look like this. Why? Because of the nature of the squaring. Because when you square it, here I'll show you on the whiteboard. Say it looks like it's about to go into the negatives, and then because it's squaring, it'll do it. Because the negatives get squared and they go, yeah. Okay, moving along. Where's class example 1? Did I miss that one? Oh, it's on the first page. Okay, let's do class example 2. Okay, let's skip down to B. I hate fill in the blank. It says the graph of this function has x-intercepts of x equals -2 and x equals 3 with a y-intercept of -6. You guys okay with that? -2, look at my screen, x-intercept, +3, +3. Y-intercept -6 is here on the y-axis. What's special about a y-intercept? No, it's not the vertex, no. What's special about the y-intercept? There's only one thing that's special about it. Very nice. X equals 0. And what's special about the x-intercepts? Good, the y equals 0. So if you can remember that, your life will be good. You absolutely need to know about x and y intercepts. So how do you find an x-intercept? Make y 0. How do you find a y-intercept? Make x 0. So you just do a switch. You can see that the function has been factored and you solve these individually. I'll use my highlighter. Solve and solve individually. And you get the opposites of those binomials, -2 and 3. Zeros, x-intercepts, and roots all mean the same thing. That's why all the blanks are the same. They're really trying to beat that into you, I guess. X-intercepts, roots, and zeros all meaning the same thing. Are we clear on that? Okay. Now, this is using technology. So you can put that here. Okay, this strategy that I'm going to show you is a technique for you just to make sure that you're doing it right algebraically. Hi. Come here. Anybody else need a calculator? Come here. Jason Bourne.
Those are my favorite movies. So good.
I know, right?
He was like my first boyfriend, really.
Same.
And do you ever watch Stargate Atlantis?
No.
Oh.
What's the function again? 2x squared minus 7x?
Yeah.
I'm out. Plus 3. Okay, when you hit graph, if you notice my graph's all messed up because I don't have the right window. If you're ever stuck on your window, you can always hit zoom 6. Zoom 6 is your standard window. It kind of just resets it so it's centered around 0 with 10 to the left, 10 right, 10 up, and 10 down. Now, with this, you can see both the roots. Do you see there right here and right here? Now, I'm just going to zoom it in a little bit. So in order to do that, I'm going to go into my window. And do you see the minimum and the maximum for x and y? Do you guys see those? So x minimum, that's your left boundary. And right, or x maximum, is your right boundary. So I'm just going to cut those in half to 5. It just means I'm going to come in a little bit closer on the x-axis. And I'm going to do the same for the y. Y minimum is your lower boundary, and y maximum is your upper boundary. And that SCL stands for scale, and it just tells you how much each tick on the graph is worth. So you can see with this window, it's 5 to the right, 5 left, 5 up, 5 down, and an individual tick is worth 1. So you can see that the zeros are here and here. Now to use technology to find those, so please set your window to mine, and it'll match. And while we're waiting for you guys to set the window, you can write this down, these steps, so that you don't forget, okay? So everyone's got the window? Everybody's got the function typed into y equals? Right? Okay? And then here's the graph. So in order to find the x-intercepts using technology, which is your last resort, by the way, or your first, just to get the answer so that when you do your algebra, you'll get the matching. Like in a 20-1, the goal is not to use the calculator. In 20-2, yes, the goal is to use the calculator. So here, keep in mind that we want to focus on our algebra about 99% of the time, using technology as just an aid. Okay, so here we go. Second function, trace. The yellow button, and then trace. And this is where you live. This is where all your calculator functions live. You have value, 0, minimum, maximum, and intersection. Those first 5 are for us. Which one do you think we're going to be doing? Yeah, we're solving for zeros, right? So click that one. So you can press down and enter, or just hit number 2, whatever. Now the calculator is prompting me. It's saying left boundary. So I need to pick one. Which one am I going to go for? Here, I'll go for that one right there, because it's closer. So left boundary means I just need to be to the left of my answer. Hit enter. Now it says right boundary, so then I got to go past it. Now I'm on the right of it. Hit enter. And what happens is the calculator sets a little interval here where it's going to search. Then you hit, so see it says guess, hit enter again. And it's giving you an x value of 0.5. You probably did the left bound, right bound stuff wrong. Okay, so you go second trace, number 2, and I'll do the second one now. So I got to get closer to the second one. It's over on the right there. But the calculator prompts a left boundary. So I got to make sure I'm on the left of it. I know the 0 is on the x-axis. Right now I'm on the left of it. Hit enter. Now it wants me to go past it, do a right boundary. So now I go past it, and then I hit enter again. And what the calculator does is it puts these little arrows on the screen, and it tells the calculator to search in this neighborhood. And then it says guess, so hit enter, and I get x is 3. Left boundary means you need to set a point. It's like a marker. Left. So, for example, if you're trying to locate star, and the calculator says left boundary, press enter over here somewhere. Then it says right boundary, press enter over here somewhere. And then it's going to say guess. And what it'll do is it'll search in this neighborhood for star. Well, you just move over closer to that one and do a left bound and a right bound. For each intercept, yeah. Okay, so back to the lesson, and let's try to think about why. Fred, be kind. Okay, let's make sense of these answers. So we used the 0 feature. We got x equals 0.5, x equals 3. You guys agree? And then we're just going to sketch this. There was a 0.5, a 3, and I think it did something like this, right? So put the x-intercepts at 0.5 and 3, give it a nice little U shape, and there's your sketch. Okay. Now using algebra. So if you can factor, and that's a big if, because sometimes you'll get random ones that can't be factored, like using whole numbers and stuff like that we're used to. Okay, so let's take a look at our polynomial expression. 2x squared minus 7x plus a 3. What's the AC value? And 6 factors so that you get to 7. So it'll be 6 and 1. Which one's negative? Both? Alright, so 2x squared minus 6x minus x plus a 3. Taking out 2x, I get x minus 3. Take out a negative 1, I get x minus 3. This factors to 2x minus 1 and x minus 3. Now let's make sense of these factors. Let me blow them up. The 2x minus 1 factor, if that was equal to 0, what would happen? Good, x is half. Like cover up the 2, cover up the 2, and you would just have a 1 there, right? And then cancel the 2 by dividing. In other words, move the 1 over and divide by 2. Okay, is that the same as this? Just in decimal form, good. And now we have, I'll change color so it's obvious. That one over here, x minus 3 equals 0. Move the 3 over and you get x equals 3. Who are you supposed to be? Alice? Who's Alice? Yeah, who is it? Oh, I've never seen that. So I grew up on The Lion King and Aladdin. No. No. Just math right now. We could talk after. Timon and Pumbaa? Those are my boys right there. But actually though, like when Scar kills Mustafa, like how is that for a child, eh? That was the day I became a man. I was like 8 years old or something. I watched Mustafa fall to his death. It's terrible, terrible, sad story about Mustafa. Same thing. Same diff. What is it? Mufasa? Oh, my favorite? Rafiki. Rafiki. Yeah, Rafiki. He's like, squish banana. Okay, back to the math. To find the zeros of a function, yay. Either, and don't even say either, because one of them is cheating. Just kidding. It's there in case you need it. This one in red, like, it's there to help you. It's there as an aid. It's there to help you. It's like support. Now, like if you go to, say, University of Alberta and try to take a calculus course, they would never ever allow you to have a graphing calculator in there to help you. So, you know, at some point, if you think that's your goal, then you're going to be really working, you know, sans calculator. Anybody speak French in here? Did I say that okay? Or is it sans? Sans. Okay, so this is the big one here. You substitute 0 for the y, and then you find the roots using algebra and factoring. Okay, so let's take a look at class example 4. So if it says, for this equation, it says find the root, it has to equal 0. Okay, so if you ever see that, find the root, make it equal 0. So why do I move the 33 over and not the other two? Which one do I like positive? The lead, right? The lead, which is the highest degree. Now, can we think of the factors of 33? 11 and 3. So this one's very straightforward. 11 and 3. Which one's negative? To keep it positive 8. So positive 11 minus 3 gives 8. And the two solutions, therefore, are negative 11 and positive 3. Thank you very much. These are the roots. So how long do you think we're here for? Because Mr. Fox said that we'd have extended lunch. There's no east. Well, they'll probably give us an announcement. So how much time do we have? I'm just trying to ballpark this. Oh, thank you. That's what I was looking for, Fred. So let me get through these class examples, and then I'll let you guys work, and then there'll probably be an announcement directing us what to do. Now, moving to the second one, Moving to the second one, all the work's been done for you. You just have to finish it off. So let's take a look at the very first thing that's easy. This one. What's easy about this? That's very simple to make 0. Now what about this one here? Hey guys, let me ask you a little question about 6. Is 6 ever 0? Or is 6 always 6? 6 is always 6, right? He's constant. Always. He's always 6. So 6 is never 0. So don't make that mistake. Don't do this. This is very bad. Okay? That is bad. Bad, bad, bad. However, if you look at the next one, the one that's not so... Hi, what's up? Only if it was 6x. If it's 6x, then yes, this is good. But we don't have 6x. We just have 6. So we don't want this. This is bad. Now over here, this term here. And I'm just going to color over that 4. What if that 4 wasn't there? What's the opposite of plus 5? So for those of you that are just getting used to this, put -5. But there's something in the way. What is it? So divide it out. How's that feel? Okay, how's the minion feel? Good? Are you a minion? That's good. I like those. It's like real life minion. Where you get those? They're pretty wild. You did a good job. I'll have to get a closer look later. Next one. Six. 6 is always 6. 6 is never 0. Call! Okay, next one. Hi. Is it equal to 0? So that step's been done for us. Is it factored? Okay, what could I do? Always do GCF first, and you get taking out a 2, and you get... Now, what do you see? Good, I hear Tahir over there solving it. What a machine. So, now, looking at this one, and we'll go from right to left. This one, what does it give us? Okay, and this one? Oh, the opposite. We're trying to make it 0. What value would make this whole term 0? Because 0 times anything will be 0. Did you catch that? And then the last one, what do we get from this one? Nothing. That's bad. Bad. You bad, bad boy. Sorry, I'll stop. Okay, and then just to make this a little bit cuter, we go like this. You want it to be as cute as possible. That's your goal in math. Cute as possible. Okay, for class example 5, not only do they want us to find the zeros, but they want us to find the y-intercept. Now the y-intercepts are extremely easy. I'll do those first in purple. Okay? So, for a y-intercept, the x is 0. So check this out. F at 0 would be 5 times 0 squared plus 15 times 0 minus 20. F at 0 is minus 20. So why was that so easy? Good. So look at the function. Take x, square it, and times it by 5, and then add x times 15, and then subtract 20. Does the first term depend on x? Does the second? Does the third? What's the third? Negative 20. He's always negative 20. Right? So when x is 0, you have the y-intercept, the constant. So you come to realize that the y-intercept is the constant. So what's the y-intercept for the next question? So f at 0 would equal 10. Now what's the constant in part C? And don't say 1. Very nice. You have to FOIL. So come in here, you get 4x squared plus 2x. What's the constant? Yeah, you're right. There's a 0 there. So if you don't have a constant, it's because it's 0. So that's your y-intercept. So g at 0 is 0. Okay, now we got to do this algebraically, solving for zeros in the black ink. First one looks like something really easy in the first one. Take out a 5. Good. You get 5 taken out. You get x squared plus 3x minus 4. How to solve this one? 5, 2 brackets. What's going in there? 4 and 1? Which one's which? Negative 1 and a positive 4? Okay. So in order to solve this, you got to make the left side 0 and then decide on the opposites here. This would be negative 4 and positive 1. Okay, so we got a y-intercept and we got our x-intercepts. Next one's a little bit more challenging because they have an a value that's not 1. So what's the AC value? 30. How does 30 break down? No, 15 and 2 won't work. 6 and 5? Okay, 6 and 5. Which one's negative? Both? All right. So we're going to rewrite f at x as 3x squared minus 6x minus 5x plus a 10. We're going to set the left-hand side to 0. We're going to put these in groups. We're going to take out a GCF. What do we get? 3x, x minus 2. And take out a minus 5, x minus 2. Now we can take out the 3x minus 5, and you have the x minus 2. Solve these individually. What do you get? 2's the easy one. Now the other one, cover up the 3, and it would be 5 divided by 3 5/3. And for the last one, remember we distributed? So just head back to the factored version. This one gives x equals 0, and this one gives x equals negative 1/2. Okay, whoa. Okay, so factored versions for x-intercepts, distributed versions for y-intercepts. Look at the constant when it's fully distributed for a y-intercept. Look at the x's that make it 0 when it's fully factored for the x-intercepts. Any questions before I let you be? One more practice.
Okay, no.
Okay, I'm pretty sure we could do this. I'm going to show you some tricks on the calculator. I know you guys like that. So what's the function again? 3x squared plus 4x minus 7. Okay, please follow along. Second trace. Number 2 for the 0. I just kept clicking till I found my cursor. See my cursor? You have to go to the left of it. Hit enter. Go to the right of it. Hit enter. And I got negative 2.333. Now you gotta be careful. Gotta be careful, careful, careful. Watch the tricks. You have to have this screen though before we can move on. I'm gonna wait till everybody's got this screen. Everybody got this screen? Negative 2.333? It's gotta say that before we can move forward. Do you want me to do it again? Do it again? Second trace. Number 2, 0. Make sure the cursor is to the left of the most left intercept. Hit enter. Go to the right. Hit enter. And then hit enter again. Okay, now right now, the calculator has this number stored locally in its memory for x. You're going to go second mode, which quits. Now you have this screen, right? Hit X, enter. X is right underneath mode. It should be the same value that was stored locally from your graph. Now you can hit math fraction. You typed it in funny. You have x squared in the power. So now I know the fraction for my x-intercept. Answer, well, I hit math fraction, yeah. I hit x, hit enter, and then I press math fraction, enter. One second. So we know that x is negative 7/3. Okay? To make this the binomial, you have to work backwards. Times 3. And then bring the 7 over. You're like working backwards from the calculator. So I did one of them for you. I'm not going to do the rest. If you really want to learn this class example, rewatch the video and learn your calculator or get help from me. I'm going to let you be. I'll come see you guys individually. Let's make sure we're getting number 1 and number 2 done. And all of this page. And that should be enough. I would make you guys do everything all the time, so do everything, and then if you want to do every second question, then that's your choice. But I always recommend do everything.